Electron configurations. Now, I know that you used and you learned some about electron configurations in biology, but now that we know about the periodic table, we can do it the easy way now. So, if you don't remember from last year, don't worry about it. This is really easy. Okay. I love this periodic table because it gives us 4 different colors. And the colors are orbitals, different orbitals. This blue is an s orbital. And an s orbital looks like a sphere. It's good that it's named S, isn't it? Because it helps us to remember a sphere. Each sphere can hold 2 electrons. Now, if you'll notice, in the blue, it has 2 columns. So each of those is place for 2 electrons. Okay, this yellow over here is a p orbital. P orbitals, I remember them and call them propellers. And there's one going across, one going up and down, and then one is sticking out 3D back and forth. Now, in each propeller shape, we can have 2 electrons. So 1, 2, 3, 4, 5, 6. P's can hold 6. Now, if you notice, 1, 2, 3, 4, 5, 6. You don't really have to memorize how many they'll hold because you can count across. Okay, in the pink is a d orbital. I think about D's as being a donut shape, but they're really strange donut rings. So I'm not going to try to draw them. But can you guess how many there'll be in the donut shape? Sure, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 elements across, and so each D energy level can hold 10. Now, there's not just one S. There are 7 S's. And we know where we are because of these numbers going down. 1, 2, 3, 4, 5, 6, 7. These are called energy levels. Okay, so sometimes when we try to write out the electron configuration for an element, and I'll go back to hydrogen, some people are trying to say, whoa, we're not doing hydrogen, we're doing carbon. Why are we talking about hydrogen? Well, just like a Lego house that you're building up from the ground floor the same way every single time you build it, the electrons are the same in the same configuration for each element. So carbon's electron, this first one, is just the same as hydrogen's electron. And carbon's second electron is just the same as helium. So I can look at the periodic table as a blueprint for how to write any element's electron configuration. Let me show you how. Let's look at carbon. Carbon is number 6. We know that that has 6 protons. Now, if it's uncharged, it also has 6 electrons. So, we have to place each of these electrons in its configuration. Well, we go back to hydrogen and rewrite where its electron is. So hydrogen is on the first energy level, that number right here, so we'll write 1. It's in the S block shape, so write an S, and then it has 1 electron. So this would be the electron configuration for hydrogen. But we want to keep going because we're not to carbons yet. So helium, for this exercise, we're going to imagine helium is over here in this empty block. So helium is still on the first energy level. It's still in the S block, but now it's the second one over. And remember I told you that each S can hold 2 electrons per energy level? So I'm not going to come over here and write 1s2. I'm just going to show that there's a second one up here. So I'm going to change that little 1 to 2. So that means helium's 2 electrons are on the first energy level in the S shape, and there's 2 of them. Pretty easy. Well, let's count to 3 now. 3 is lithium. So to get to 3, we had to drop down to the next energy level. So I'm going to write a big 2. Lithium is still in the blue S shape, and it's the first one there. But carbon is still on, going forward. So I need to go to beryllium. Beryllium is the second one on the S shape in the second level. So I'm going to change that 1 to 2. Now, 5 is in this yellow, and remember the yellow is a p orbital. It's still in the second energy row level, but now I'm going to write a p, and boron is the first one there. Okay, and now we're finally up to carbon. Carbon is the second one in this second p energy level. Now, a good way to check this is to add up these numbers. 2, 4, 6. That means 6 electrons. Carbon has 6 electrons. This is the energy electron configuration for carbon. See, pretty easy. Let's go to magnesium. Magnesium is number 12. So, one good thing about this is magnesium's is just like carbon's, only it has more added on to it. So to do magnesium, all I got to do is rewrite carbon and then keep going. So how many p electrons can be in the p in energy level? Do you remember how we figured that out? We count them across. So carbon is the second one through. Nitrogen would be the third one. Oxygen's 4. Fluorine is 5. And neon is 6. So I'm going to change that 2 to a 6 to show that the p orbital is completely filled up on this second level. Now I'm going to drop down to sodium. Sodium is on the next energy level, so I'm going to write a big 3. And we get that from this number that I have covered up over here. Now, we're back to the blue, and the blue is an S. Sodium is number 1. But magnesium is the second one over in this, so I'm going to go ahead and write a 2. There we are. That's magnesium. Pretty simple because I already knew carbons. All I had to do was add on. Okay, let's do another one. Let's do iron. Iron is 26. Whew, that's a lot, isn't it? Let's go ahead and move this up so we can start over and write to 26. Okay, So we're going to start over just like we did before with hydrogen. Hydrogen's on the first energy level. It's in the S block, hydrogen, helium, 2. Now we go across, and we've already done helium, so let's go down to 2. And it's still in the S, and we have lithium and beryllium, 2 more. And then we go across to the yellow. Yellow is still on the second energy level, but now it's a P shape, and we have boron, carbon, nitrogen, oxygen, fluorine, neon, which are 6 more. Drop down to level 3. Back to an S shape, and we have sodium, magnesium, 2 more. Then across to 13, which is still on the 3rd level. We are down to P's now in the yellow. Aluminum, silicon, phosphorus, sulfur, chlorine, argon. 6 more elements there. And then down to 4, which is potassium and calcium. Those are both S's, potassium, calcium. And we're at 20. Let's check and make sure that we're at 20 before we go on. So remember, I'm going to count these small numbers up here, the number of electrons. So 2 plus 2 is 4, plus 6 is 10, 11, 12, 18, 19, 20. Okay, I'm right where I'm supposed to be. So now I'm at 21. Oh, 21 is a different color, isn't it? And there's also something a little bit different about when we move over to this color. Now, 21, if you count down, you would still say, well, it's on the 4th level. But actually, when you move over to this pink color, we're going to drop an energy level. So these are going to be 3s again. Now, what letter are these? Do you remember? D's for donuts. So 3D, and then how many over is iron? Let's count again. 1, 2, 3, 4, 5, 6. 3D, 6. Okay? Does that make sense? This is the electron configuration for iron. Now, if you can do this one, you can do them all, I think. Because you could just keep going. Just remember to drop down when you go to the pinks. So let's do the absolute hardest one that you are going to have to do, which is 56, barium. Okay, 56. And to make it easier on me, let's stick with this iron that we have, and let's add to that. So I'm going to take my 6 off, because I'm not going to stop there. And let me get my little pointer. I was at 6 here. 7, 8, 9, 10. D's can hold 10, and I'm going to completely fill up this D. Now I am over here at 31. And we scoot back to this 4th row. Okay, so I'm going to write a 4. And then that's on the P shape. And do we have all of those filled up? Sure. Because I'm going to go straight through this. 1, 2, 3, 4, 5, 6. Krypton. 6. Okay. Now, barium is still onwards, so I'm going to go to 37 here. We are down an energy level, so now I'm going to write a 5 with my pencil, not with the marker. 5. And then we are back to the blue S's, and it is 2 of them. Okay, now I need to go on to 39. 39 is to the pink D's, so I know I need to drop an energy level. So instead of 5, I'm going to go back to 4. And then how many across do I have on here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm still needing to go forward to get to barium. So I'm going to fill in all 10 of these on the D's. 4D, 10. Now I'm going to go on 49. We are back to yellows, and that means we jump back up to the 5th energy level. So 5. Yellows are P's. 5P. And then as I keep counting, 1, 2, 3, 4, 5, 6. I'm going to fill up that P. Then I'm going to drop down to the 6th energy level, which is cesium. And we have back to S shape. And there are 1, 1, 2. And we are at barium. And that is absolutely the hardest one that you'll have to do. So if you can do this one, you can do them all, because you'll just be marking them off or backwards as you go. Okay? And to make sure you're at barium, remember you can add up all of these small numbers and make sure they add to 56. And they do. So, this is electron configurations, and that's the long version of it. Now, there is a shorter way to write these, because if you were talking about these in a scientific manual, these would be long to print out, wouldn't they? So, there are some short ways to kind of abbreviate these. And let me show you how to do that. Okay. These gases at the end are called noble gases. And they are at the P levels, and they're the completely filled up P versions of the electron configurations. So they all end in P6. So, or except for helium, but remember helium is really over here, okay? So neon would end in 2p6, and argon would end in 3p6. Krypton would be 4p6. So, instead of saying 2p6 here, I could say whatever its element is, and then I could abbreviate anything on the next row just by adding its electron configuration to the end of kryptons, or the end of argons, or the end of neons. Okay? Now, I know I'm probably not explaining this very well, so let me just show you how to do one. Let's look at magnesium again. Okay. Magnesium is it goes through 3s2. So here is the last part of magnesium. And this is the first part of magnesium. Now, we can take this part that ends in this 2p6, and we can say that it is the same as neon. And I'm going to put a bracket with the symbol for neon in there. And then I'm going to add on just this last part, 3s2, and show that magnesium is the same as neon plus 2 more. Okay, does that make sense? It's a little faster to write that way. Let's look at calcium. Calcium is the same as argon, right? So let's write our bracket with argon symbol in it. And then I'm just going to count up to calcium. Calcium would be on the 4th energy level right here. And then it's the second one over on the S. So that would be the abbreviation for calcium. Instead of doing all of this, I can stop right here at argon and then just add on this. Okay? We'll do some more of these in class later. But I hope you understood this.